Hello everyone and welcome back. My name is Mr. Koval, and in this video I'm going to go over how to interpret chemical equations. So let's get into this. So a chemical equation or chemical reaction is basically where you get substances that react to form new substances. So for example, if I write it as a word equation, I have hydrogen plus oxygen reacting to form water. So, thing I want you to notice is that the reactants are always on the left side and your products are always on the right side of the arrow. So this arrow is indicating the directionality of the reaction. It's always going in this direction, unless of course you have a reversible reaction. But even so, whatever's on this side of the arrow is always considered the the reactants, and whatever's on the right side of the arrow is always considered products, even if you have a reversible reaction. So if I was to write this in terms of the molecules, right? So hydrogen would be two hydrogens bonded together, and I have two molecules of hydrogen, and that's going to react with one molecule of oxygen, and that'll form two molecules of water. And so the thing I want you to see here is that there's a conservation of materials, a conservation of atoms. Atoms are not created or destroyed, they're just rearranged. And so this is in line with the law of conservation of mass or matter. And so you can see that we have over here 4 hydrogens. And then on this side, we have 1, 2, 3, 4 hydrogens. Okay. And then over here, we have 2 oxygens and we have 2 oxygens. So everything is conserved. The number of oxygens is conserved. The number of hydrogens is conserved. So this is in line with the law of conservation of mass. Okay, so if we were to write this in formulas, this is the way the reaction equation would look. This is our chemical equation. And I want to point out a few things about our chemical equation here. First, we have the molecules. So H2, the formulas for the substances. So H2, and we have O2, and we have H2O, right? So here's what it looks like bonded together, and there's a formula, H2O, H2O. So here we have hydrogen, H2, 2 hydrogens bonded together, O2, 2 oxygens bonded together. So we have the formulas for our reactants on this side. Remember, reactants are always on this side of the arrow. They're always on the left side of the arrow, and the products are always on the right side of the arrow. So it's always pointing towards the products. Another thing I want to point out is these symbols here. So whatever comes after the substance in parentheses is the state of matter. And there's 4 states of matter that you'll find. One is gas, G is for gas, L is for liquid, S is for solid, and then we have AQ. AQ stands for aqueous, which means that it is dissolved in water. That's what aqueous means. So if you see AQ, it means that whatever that substance is, it's dissolved in water. And the last thing I want to point out here are these coefficients. The coefficients here tell me how many of each reactant or product I have in my equation. So here I have a coefficient 2. That means I have 2 molecules of hydrogen. So just like here, I have 2 molecules of hydrogen, so I get a coefficient 2. And then here I have 1 molecule of oxygen. We don't write ones in our equation. So for the coefficient, you're not going to have a 1 there, but it's there because we have O2 there. So we got 1 of these. And then we have a 2 coefficient here for our waters, telling us that we formed 2 water molecules, just like we see here. So we have 2 for the coefficient. And if you look at this, you can see that it's balanced as well. If you multiply the coefficient by the subscript, you'll get the total number of that atom for that molecule. So here we have 2 times 2 is 4, so we have 4 hydrogens. And then here we have 2 times 2 is 4 hydrogens, so that's balanced. Here we have 1 times 2 is 2, and here we have 2 times 1 is 2. Again, we don't write the 1 for the subscript, but it's there. So 2 times 1 is 2, so the oxygens are balanced. So this is a balanced equation. And then finally, I want to point out that in some reactions, they require special conditions to get the reaction to go. So for example, I can reverse this process here. I can create oxygen and hydrogen from water by applying an electrical current through the water. So if I write that in as an equation, I have 2 water molecules here, liquid. I run an electric current through the water, and then these 2 water molecules will break down to form 2 molecules of hydrogen gas, 1 molecule of oxygen gas. So in order to get this to go, you need an electrical current. So that's what's written over the arrow. For this one, where you have 2 KClO3 potassium chlorate, in order to get the potassium chlorate to break down and form potassium chloride and oxygen gas, you need to supply heat. So if you see a triangle over the arrow, that means heat is supplied to get the reaction to go. And it's a continuous supply of heat. So in this reaction, I have 2 KClO3 solid. I apply the heat, and that allows it to break down into potassium chloride solid and oxygen gas. So look out for anything that is above or below the arrow as a special circumstance. Sometimes you might see catalyst written under the arrow or above the arrow, indicating that in order to get the reaction to go, you have to supply a catalyst, and so on. So that's it for this video. If you enjoyed this video, if this was a good primer or introduction to chemical equations and you enjoyed it and you learned from it, then by all means, like the video, share the video, hit that notification bell, or hit that like button over here. Also, subscribe to my channel, hit that notification bell. When you do, make sure you click all so you can get notified by all the videos I put out. And then finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a question or a problem you want me to help you with, put it down below. If you have a topic you want me to cover, put it down below. I would love to do that for you. Thanks for joining me, and have a great day.